So this first one, when 5 equals 5, does it make a triangle? What about 4, 6, 8? What about 2, 4, 8? 3, 4, 8? 3, 5, 7. All right, so when A plus B is less than C, what happens? Okay. What about when A plus B equals C? What about if A plus B is bigger than C? Yes, a triangle. Okay, what's true about C? Every time? Yes, true. But when you look at the 3 lengths, what's true about C every time? C is the longest. So when we go to look at any triangle, we need to make sure that if we take, and it's really any 2 sides needs to be greater than the third, but the one we really need to check, we need to take those 2 smaller sides. Is it bigger than the third when you add them together? Okay. That is the triangle inequality theorem. And guess what? I didn't even have to teach it to you. You figured it out yourself. Aren't you so proud of yourselves? Yeah. Okay, get out your student journal and turn to page. We're going to start at page 187. I know that'll feel weird, but just trust me. Okay. 187.
Does this have to go back in there?
It does not have to unless you want it to. But the block should go back in the bags. I know, it's so sad. Yeah. Okay, so on the bottom of page 187, we're going to talk about the triangle inequality theorem because you just figured it out just there. Okay. If we take the sum of any 2 sides, it better be bigger than the third. Really, the biggest one we have to test is just making sure our 2 smaller ones add up to be bigger than the largest side, because everything else should fall into place. Okay, so I would like you to write this down. What if I had a triangle with sides 4, 9, and 10? Is today soft shell taco for lunch? Mac and cheese? That makes sense too. You can like smell it coming through the vent. Can you guys smell lunch? No, you can't smell it? I can smell lunch coming through the vent. Okay. Does this make a triangle? What do you think?
Yeah.
Is 4 plus 9 bigger than 10? Yes. We make a triangle. It's as simple as that. And I mean, we can check, is 9 plus 10 bigger than 4? Yes. Is 4 plus 10 bigger than 9? Well, yes, because that 10 is already bigger than the sides anyway. Okay. So really, I mean, we wouldn't have to check all of these.
It is.
Oh, okay. Really, the biggest thing we have to check for is to make sure those 2 smaller sides add up to be bigger than the third side. Okay. So what if we had 8, 9, and 18? Write it down first. Already, Braden is saying no. Do you agree with Braden? Okay, Sam, why is it no?
8 plus 9. Oh, yeah.
8 plus 9 is 17. which is smaller than 18, so no. No triangle. You realize that we're over here on 187? Yeah. Mm-hmm.
We were.
Mm-hmm. Mm-hmm. It's fine. All right. Now. What about 5, 7, 12?
No.
5 plus 7 equals 12. So no triangle. It has to be, they add together to be bigger than that third side. So what I'm going to have you do, I'm going to have you think about this. A triangle has side lengths of 14 and 9. I want to know what could the third side be? Is there one specific number that's an answer? No, there could be a lot of numbers, right? So how is it going to be best to write our answer?
Greater than. No. The third one is to be the biggest one, right?
What numbers can it be bigger than? Well, okay. So what happens when we subtract 14 and 9? 5. So we would have to make sure that our third side is bigger than 5. Because if our third side was 5, it wouldn't work. But if it's like 5.2, we're good, right?
So 14 can be the number.
It could be, yeah.
Exactly.
It doesn't say which one. Yep. Now, what is 14 plus 9?
23.
So our third side would have to be smaller than 23. Because if it's 23, 14 plus 9 is 23, and that wouldn't work either.
5. 6.
It could be bigger than 5, but less than 23. 5.1 could be a side length, Braden, right? Okay. So how did we get these numbers? Added and subtracted to get the end caps.
So.
Okay.
Oh yeah. So is there like no distinct way to count triangle sides? Oh, like you don't add them and subtract. No, what I'm saying is there's like numbering them. There is no like you start from 1 to C is the vertex.
All right, now let's go back to the page on the left. Okay, we are going to talk about how we know longest side, shortest side, biggest angle, smallest angle. Okay, so here we go. Do you see this triangle right here? Do you see how BAB is the bigger side?
Yeah. Mm-hmm. Yeah.
Compared to BC?
Yeah.
Well, the angle across from the longer side is going to be bigger than the angle across from the shorter side. I mean, that feels like that makes sense, right? Okay. So draw this triangle with me here. Okay. What angle is the largest? So since JL is the longest, what's across from it? K. Our largest angle is angle K. What's our smallest angle? And then angle J would be in between. That's not fair. Yeah. Okay. Guess what? We have the same rules, but with angles. Okay. If angle A is bigger than angle C, then the side across from the bigger angle is longer than the side across from the smaller angle. Right? I mean, so it goes both ways, right? True. So what side would be the longest of them all? AC would be the longest of them all. So I want you to draw this for me. I just reversed it.
That is a 51, a 47, and an 82.
Okay. Okay, so what's our longest side? Okay, our biggest angle is 82. So across from 82, our biggest angle is our longest side, DE. Our smallest angle is E, 47. So across from it is DF, our shortest side. And then EF would be our middle one. So what I want you to do is turn the page. I want you and your elbow partner to answer numbers 6, 9, 10, and 13. 6, 9, 10, and 13 on page.
Yeah.
So all we're doing is number 6,
Oh.
number 9, number 10, and number 13.
Nine, yes.
Okay, now we have 9, 10, 13.
No.
Right.
Wait, are you getting no? Yeah.
From the 19.
13. 15.
So then it could be. So it can be,
So 8.
so it can be. Can be
8 and 18.
but it can be-
All right. In number 6, it says order them from smallest to largest. What's the smallest angle? Angle C, then angle A, and then angle B. Do we all agree with those? Okay. In number 9, yes or no? What's 3 plus 12? 15. That's less than 17, so no triangle. Okay. What about number 10? What's 5 plus 12? Oh, that's 5 plus 16. Sorry. Wait, hold on. Number 10, 5, 21, and 16, right? What's 5 plus 16?
21.
Oh, man. No triangle. So you need to add the two smallest together, okay? That one tricked you because they weren't in order. So the smallest two. Okay. Now, what about number 13? What do you have, Braden?
Actually larger than 8 and less than 18.
How did Braden get those numbers? Adding and subtracting 5 and 13. Okay. Okay. So I know we only have a few minutes left, but that's literally all this next part is going to take. So turn to 191. Okay. So this is the same kind of thing, but into triangles. Okay. Into triangles. I have two pairs of sides that are congruent. Do you see that? This side is congruent to this side. And this side congruent to this side. That has to happen for step 1. Step 2, who has the bigger angle? Well, V is a larger angle than 35. So guess what's going to happen? The side across from WX is larger than the side across from R. Same thing, right? That we kind of talked about, we're just in two different triangles. Okay. Same thing happens with our angles. Okay. Notice how I have two pairs of congruent sides. All right. Who has the bigger side across from it? AB is bigger, correct? So guess what? Angle C is going to be bigger than angle F. Okay, so go to the next page. Answer 1 through 6. It's kind of like our in-class homework. I'm going to give you a graded worksheet because I think this is easy and I would like to give you a grade on it. Talk to each other.
How do you do this?
Okay. Oh, sorry.
You said 1 through 6.
I did say 1 through 6.
All right. In number 1, which one is bigger? EF, because 45 is bigger than 35. So EF is what we choose. Okay. In number 2, BC or EF? BC, because it's across from the bigger angle. Ooh, but what happens in number 3? They're the same. Okay. Ooh, what happens in number 4? They're the same exact triangle. Yeah. This is not equilateral, but notice how I have congruent sides, congruent sides, congruent sides. For an equilateral, our 3 pairs of sides are congruent. Side, side, side. Side, side, side. You remember that? SSS. Okay, over here, who's bigger, angle A or angle D? Angle D, it's across from the larger side. In number 6, who's larger, A or D? A, it's across from the larger side. Do you think we can handle this? I think we can. Okay,